Do I unmute? Can you guys hear me?
Yeah, clearly.
Cool. Hello, welcome back. We got a lot of people today. That's good. That's good. A lot of action, a lot of movement. Hi, Mark. Welcome. Hey, Doe. Well, I think today we're gonna do like kind of a demo of the new Signal stuff. Bit of a status update there. Kind of just show what we're like, where we are. Talk about what's left. Show off the new stuff, and then take questions. Help people with their code. Get feedback. Um, so maybe like 5-10 minutes. You're gonna see my face in my screen if I can figure out how to do that on GitHub or on Discord. Entire screen. Cool. Hello. Can I show my face as well? Does it put me in the corner? Oh well. Okay. You can see me. It's like two different windows. Cool. Okay. We're gonna do this. Getting into like the new Dioxus. So we've been working on this PR for quite a while now. Like 2 weeks, 2-3 weeks. The goal is to ship this by the end of January, or at least be technically complete by the end of January. It'll still probably take like a week or two to get docs up, maybe like mid-February. Um, this is the big PR that's been rolling. I think almost 300 commits. We'll definitely be hitting 300 commits by the end of this. Um, a lot of stuff has changed, and then yeah, Mark and the community's getting involved. A lot of people. Um, this still is like a decent idea of like the to-do that's left, and this has been the to-do since like 2 weeks ago. So there's been a lot of stuff that's been happening. Um, Mainly where we are right now is everything is functional. A few things don't work, and APIs are shifting around. So I know, Mark, you've been like playing around with the new API and getting it to work with Freya. Um, some stuff works, some stuff doesn't. But I do kind of want to go over like what's new, what's different, and what's cool about it, and why it's like better than the old version. You can get some feedback on like what the community thinks, if there's any changes or any fixes, or just like questions that we should probably clarify in the docs when we release. Get some of that information out now, so it's better before we release it. Without further ado, just make sure I get full. You guys can see my screen, right? Make it bigger.
Yeah, we can see.
Okay. You're on mobile. Sorry. I'll try to make it big. So we've updated some of the examples. We removed some examples that are just bad. I do want to get an idea from the community of the examples we should add, or stuff that people would like to know more about. I think the examples have kind of been messy over like the past year. We like add stuff to sort of like ad hoc tests because it's like hard to test desktop functionality and web functionality. We have better tests now to do this sort of things. So the examples should be just like more useful examples. So if people can just like come up with a list of stuff they wish they had in the examples directory, common things, hard things, it'd be much better. So this is the new, like the clock example is a really good demonstration of like the new Dioxus. Um, it looks very similar to what you're used to. I hope this is big enough. It looks similar to what you're used to. We have a new launch method. You can actually just launch. Oops. This can just be launch. The reason why this is launch desktop at the moment is because Tokyo timers don't work on WASM. Um, Tokyo not working on WASM by default is annoying. You'd have to switch the timer that you're using to work on web. This is something we need to get to at some point. But the new signals are cool. They're copy, meaning you don't have to call clone. The use future takes a callback, and that callback has to be static, or the future that callback spawns has to be static. Um, so normally you'd have to clone, in like old Dioxus, you'd have to say count equals count to clone, and then you have to move it in. New Dioxus says, well, count is a copy-based state management system, so we can make a bunch of states, and we never have to clone them into the future that we're using. And it works with event handlers as well. So in theory, we could add a button on click, and it does the same thing. We don't have to clone into here as well. And then this can even be async. So Dioxus supported this in 0.4, async move. The handlers themselves can accept futures. So The errors here aren't great. Like if you return a value, like if you pop a value from like a list, the return value will be that item because you popped it. And you'll get like a weird error. It's mostly because we specialize on click to either return nothing or a future. Um, yeah, but this is cool. So you don't actually have to clone on any of your state anymore. And use futures changing. It doesn't regenerate based on its dependencies anymore. It just spawns. We have a new hook for that called use resource. Async move. The idea behind use resource is it doesn't modify state. So you're ideally this is like a value that or this is a future that resolves to a value, whereas use future is just like a handle to an async task. This is like kind of no different than spawning a future and then being able to respawn it and regenerate it over and over. Um, where APIs just change. Use resource is more similar to the solid.js API called create resource. So we're moving towards signals. Some things are reactive in nature and some things aren't. We can run this. Run just an example. I mean, it's not hyper enlightening example, of course. But yeah, it counts up if you can see it. But yeah, if you're on a smaller device, it's kind of hard to see this, but yeah, it counts up infinitely. Um, we have a little bit more involved signals example. Yeah, so same deal. We have multiple states. We have a use future. We're able to increment the value. We don't have to clone running, which is like a signal that is a Boolean. So it starts off running. You don't have to clone it. It just comes in. You don't have to clone count either. It just comes in. And we're doing some asynchronous work. And then this is an infinitely looping future. Signals are cool. We implement like these two traits with them, readable and writable. I think in theory we could do like readable async, readable write, like write async being able to like await values of a signal. But right now we just do the synchronous methods. This adds a bunch of like utility methods, so you can toggle a signal, which like if you just look at it, it's just setting. I think it's just for booleans. No, actually it's generic. It's for anything that implements not. So, um, this just toggles any value that can be inverted, and this is part of the writable trait. So you actually get a bunch of good methods that come out of this. So replace, take, you can index into things, you can map values. Um, it, Evan worked more on the map stuff. I'm not too clear on all the new map APIs, but they're pretty cool on what they can do. You can push values into it, so we're not actually calling write on the signal and then push. So here we're calling signal.write.clear. So we're getting a mutable reference to the underlying signal and then we're clearing it. Whereas this one is an immutable reference allowing us to push. So you can keep the immutability that you're used to. This is like a safe method. So if you lined up a bunch of pushes, you're never worried about read and writes conflicting because signals are backed by ref cells. And if you don't know ref cells, they're kind of you're escaping Rust's typical borrow checking, maneuvers. That's how this copy state management stuff works. Um, when you hear that, you might be like, well, I'm losing like Rust's guarantees that I'm losing the borrow checker. That's like a big reason why I use Rust. Well, actually, the write and read methods are, um, well, currently not yet. I have a branch that I need to merge into this. We wrote on top of it. But write will be take a mute self, not an and self. And the lifetimes are actually threaded through the ref cells. So this is missing the lifetime. I can show you on a secondary branch, but at the end of the day, you actually won't be able to call let running equals running.read, let running equals running.write. You won't actually be able to do this because running.write takes a mutable reference to the signal, whereas read takes an immutable reference to the signal. This will complain at compile time. So you, at least within a single scope, you get the compile time check guarantees that you're not like doing mutable and immutable stuff at the same time. You can obviously clone values, so you can running equals running.clone, and then you can start mutating running as if it were mutable. So like this is a way to get a panic. We can lint this in a number of cases. So when you run with dxserve, it'll actually either fail to compile or yell at you that you're doing something that will lead to a panic. So we can get lints in a number of places that signals don't use the borrow checker completely. Um, you can call signals, so just like the solid.js API, any signal that implements or where the inner type is clone, calling the signal clones the value. This is useful for stuff like integers and booleans and strings to a lesser extent, but when you're doing iterations through lists, it's not so great. So you would be cloning the entire list. It's not a huge deal, honestly, for like most apps. Cloning a list of to-dos is very cheap in Rust, but generally it's a good idea to call .read.iter, or I believe we even don't have iter as a method. Yeah. So the signals also implement like iterable methods. So you can anything that's like a vec of t, you can index into it. I don't think in the initial release we'll have a special like signal vec type that lets you get a signal to each entry of the vector. I think that might be coming later in the 0.5 release. It's not much to add, but it's more work, and we kind of want to ship faster. Um, I kind of want to talk about what backs signals, just like the technology here is pretty cool. Use signal is a hook. It's built on use hook. It's like the same thing that you would be building on top of. Signal new with caller, it's all this stuff. We have panic locations done in debug mode for you. So actually, if you build the signal at any given spot, and then you like do that thing where you clone running and then mutate it, or you get a borrow mute error somehow, like you're abusing, not necessarily abusing, but you've architected your app in such a way that you have the same signal twice in the same scope and you're writing to it at the same time, which you shouldn't, like it shouldn't really end up like that. But if that does happen, the error messages will be extremely precise. It'll literally tell you this running signal was created here, but this running signal was created on this line, and this is being borrowed here, and this is also being borrowed here, and it'll tell you the exact line numbers that the borrows are happening. So you're going to go fix it pretty much instantly. Ideally, this never happens, but if it does happen to you, you'll have like all of the information you need to go debug why that signal is having issues. Signals are built on copy values. So let's go to the signal implementation. Copy values are like the values that back signals that let you copy it around without having to call clone. These don't have tracking on them, so you can read and write to a copy value freely. It's like this is kind of like the more advanced, like if you're really deep into the guts of building new hooks, or like you're going to build a new router or some server future stuff, you'll get down into the weeds here. But this has no read write tracking, so this is what gives signals like the ability to move into scopes freely. Signals are automatically tracked. So we kind of see this like subscriber array, there's like effects, the ability to update stuff. Copy values are not tracked. You can read and write to them freely. Signals are really cool because we can actually isolate that tracking. So use effect. Normally, in old Dioxus, you would have to provide here. In old Dioxus, you would have to provide a dependency array, and it would look something like this. So counts clone, and then we need like running.clone, and then you get counts, and then you get running, and then these might be use state handles, so you might be able to mutate them, but if they're coming from dependencies, there's like no way to like write values back, and that's kind of a big thing of effect. So anytime here count changes or running changes, the effect will rerun, and then you'll get them as a dependency array. This is like typical React, but this does like in Rust it just gets really annoying because we have to have like double dependency or double like declaration of dependencies, and it just like everything has to be partially equal, and it just gets here. And you're cloning things. The new Dioxus, I don't know why this is. Oh, new Dioxus, the signals themselves are tracked. So if running, because this is a signal and we're using the function call syntax, or we call read on the signal, the fact that we use the signal is now isolated to this effect scope. So this calling if running won't cause the component to regenerate, it'll just mark the effect as using running. If running ever changes, So like say down here, we toggle running. This effect will rerun. So let's say print, you change the running flag. You change the running flag. Cool. And that's run signals. Oh, and then we need, oops. Well, okay. This is a beta branch. Okay, yeah, so we can like toggle the counter. We can toggle it on, toggle it off, goes up, goes down. The use futures and use effects will always rerun anytime any of the values change. So let me go back to the clock. Or effect might be broken at the moment. It's a beta branch, so yeah, this is what new Dioxus would look like. But yeah, so you can also pass signals through child components. So struct or fn child component. Signal or running signal cool. R6. Okay, so we can build a better toggle as a component. We mark it as a component. Um, Signals are always partially equal to themselves as true. So if the same signal shows up and it compares itself, it actually doesn't check the value of the Boolean. It only checks the pointer equal of the signal. And I believe you can find this in here. Maybe somewhere. Well, you have to believe me that if you compare a signal against itself, we don't actually like check the value. So it's a free comparison. So we always assert running equals running. Like this will always be true because it's the same signal. We're not actually checking the value. We can drop in this component here. Drop it in. We'll replace this toggle running. So before Dioxus, you have to call running.clone on the value that you're passing in because this was usually a reference. Signals are copy, so you don't actually have to. You can do this. New Dioxus also supports shorthand struct initialization. So our components and elements look like structs. We now finally do that shorthand thing. So this is also valid. This is pretty cool. It works with elements too, and it works with children. So you can even do like children or key. There's like a number of special property fields that you can do that with. This makes like globbing properties a lot nicer. And then we can run. Yeah, and the toggle counter button exists. So we're able to pass values in. So if you're going to do a bunch of reactivity, it's pretty easy to nest it through. You can do this with vectors as well. So we have like saved values. So if we wanted to render this component down here, and then this was a signal of vec, and then what is this type of string? Saved values. So yeah, and we can do this as well. So child value, and this will pass through. So it's really good for things like vectors because this actually costs nothing to pass this down. This is just a copy handle, and then this will always compare against itself. This component is subscribed to any changes on this vector. So anytime someone calls write.clear on it, we actually rerun the component. We don't rerun it through the, like when we go to compare props, like normal React, we diff the old signal to the new signal. But because signals are always the same to themselves, that diff is a perfect memoization, meaning where you don't actually run the component because its properties changed, because its props didn't change. Signals themselves have the read-write tracking, and this child component is implicitly subscribed to changes on the signal because of this .read. So this is very precise, right? Like this child component will never rerun because of count or running. It will only run when saved values changes. So this future won't affect it. This count won't affect it. Only when we click, clear or save, that the list will change and then the component will rerun. This is really, really good when your app starts to scale. So if you have like hundreds of components, it's very clear why exactly your component is rerunning. You can look at this like saved values thing and say, well, I know this signal is basically a dud. Like the component will never rerun unless we get like a new saved value signal, which is rare. I mean, you'd have to be swapping out exactly which signal you pass here. So it's very unlikely that this component is rerunning because of this. When you look at this component, you know it's rerunning because it's calling .read. Um, yeah, and then I have like one little cool demo. I'll start like looking at the questions. Global. Um, we got rid of Fermi completely, like it's deleted from the tree. I believe it shows up in the diff. There's a big reason why this PR is actually dropping over 4,000 lines of code, like net. It's dropping more lines of code. We've added more lines of code, but the net diff is good. So it's much easier to maintain. Um, Big reason is we got rid of Fermi, and now we just have the global signal type that exists in the signal crate. Um, it's kind of the same idea as Fermi, that you pass it a like lazy initializer. So the signal will never be initialized until you go to use it. Uh, but you declare it as a global signal type. These are statics. You can put this anywhere in your app. You can import from anywhere in your app. But this is basically equivalent to, let counts equals use signal 0, and then provide context counts, and then wrapping in a new type. So this is like a particular pattern that you would do a lot if you had to do this yourself. Uh, we kind of just do this for you. So these are signals. Fermi basically was signals, like a state management solution that was basically signals. We basically have turned Dioxus into Dioxus plus Fermi. Fermi is modeled after Recoil.js, Zestined, MobX, like those types of state management solutions if you've used them in JavaScript. Again, they implement automatic dependency tracking. So anytime count changes, anytime count changes, components that are reading count will resubscribe. Uh, Displaying a signal is considered a read. I mean, you have to read the value to display it. So we know when we look at this component that it is subscribed to count and double count. You also have global memos. So we can subscribe this callback, this like closure, to count. Anytime count changes, this value will change. And then we can cache it. So in this case, we're doubling it. You can imagine in a to-do list where we like cache the last to-do, or we cache the longest to-do, or the highlighted items. And this collection will always be in sync with this collection. So when we go to read it, this will always be double of that. And this is a cool example. Yeah, we can go up high, we can go down low. Yeah, the cool thing about global signals is, I mean, you can imagine there's like no use. Like old Fermi, you'd have to be like use read count equals use read. And this would get like really hairy the bigger components you have. So you'd be like inclined to split things up. New Dioxus says, well, you don't need any of that. You can just call a read on the signal, which is great because we can even do like a child. And then let's just do a bunch of children. Component. We'll run it again. Yeah. So we have a top level component, a bottom level component. Top level is not actually subscribed to anything. The bottom level is. You can refactor your app however you want, and then you have these global signals. We can go up high, they all increase, go down low, they all increase. With no like use read, use write, you're not passing anything around, there's no props. This is all using the global signal stuff. I think that's it for the demo. I think we should like look at questions, try to field feedback. I recommend playing around with some of this stuff. It's not perfectly, some of the API is a little weird just because it's like all in flux. But this is like the new system in a nutshell. We'd love to get feedback on better examples, things that I haven't covered that we should put in here, questions, changes, that sort of stuff. Yeah. Oh yeah, the we merged the sensing signal stuff. Like, oh yeah, signals can be sent across threads. We merged that PR, and that actually like overrode all the work I did in lifetimes, like threading it through the me itself. It will be there in the version that we release, but to get the merge conflicts working, I just erased all my own work. I gotta go back and fix that. Oh yeah, we have the OpenID Connect demo. It needs to be updated with signals. I did that in a PR and then dumped that PR, but that yeah, we need to come back and fix that. The the current OIDC example is a little weird. Like it uses a bunch of use effects and stuff. The router itself actually has way better support for doing things like running async on a route change that the OIDC example should be like taking advantage of. Does anybody have questions or code examples that we should include? We removed a bunch of like examples and kind of need like better examples to fill the repo with. Yeah, there's kind of like an open question right now. We let you build props without wrapping things in signals, and like it's kind of an anti-pattern to create a prop that's a string and then use that string in an effect or something that needs to like track that. It's like a choice. We give you more options, but it's also like kind of easy to shoot yourself in the foot. It's very easy for us to force everyone to just wrap all the values they make in signals. Uh, so I mean, you have to like balance between like what are people going to do with it and should we just force everyone into signals because like you can't shoot yourself in the foot if everything is a signal. I think like we can lint stuff, so we have access to dilint, which is basically like a clippy lint on the fly. And we can tell people that they're doing that. Same thing with like some async stuff, like cloning signals and then writing them. Um, yeah, so it's kind of an open question of like, should we do that, or do people still like the flexibility of just a prop takes a string rather than a signal string?
The unfortunate thing with a signal string for prompts would be you do have to call like read and write everywhere if you want to use it. I mean, if it's like a string you just display and it's not an issue, but there are like some downsides there as well. So if you're just using it like within the component, the string might be easier to use, but then once you start using an effect, like John said, you can like, run into photons.
I think we could lint, or like the component macro could do an analysis and then toss an error or toss a warning. But I don't know how like people building on top of use effect, like if use effect was within a function call, I don't know if that would be possible to lint. Hmm. Yeah. Okay. I think this is a good one. A question of how to do like a much larger app with signals. Uh, I'll show you like a little example. Yeah, this is kind of a takeaway from the old React world, like Redux, and I don't want to say Redux, but Recoil.js, like a number of these things, MobX, Zestin. Um, I t- like I'm always afraid of over architecting apps. I think for the most part, you should stick with global signals and then like props when possible. But it is entirely possible to do things like global stores with the signal stuff through the context API. And I actually think it's a very like, powerful way of organizing your app. Um, we'll do like a little 5 minute, like how would you organize a big app? Let me share my screen again. Cool. We have, yeah, I want text. So this is a a to-do app, we're gonna mess with it and stuff. But yeah, this is the to-do app I use to like dog food the new dog. We can run it real quick. It uses signals. The signals are cool, so it's doing like effects, it's sorting, it's using memos, all this stuff. I think it's probably crashing at the moment. Yeah, we're on the dev branch at the moment, but the approach you would take is kind of some of the stuff. What's next? So, okay, we got hello. Enter the screen. Cool. Let's say so we there's like two models you can approach, and we have examples for both of these types of models. One is just stuff your state in a struct, struct to dos, or I don't know to dos. You may have like a settings controller or something like that, enabled, cool, or like or first name, string, last name. I don't know. Let's just give a bunch of state, each, user settings. Cool. So one option is just stuff this in a struct. So use signal, that settings. So this is use signal, user settings, and then yeah, we'll just let Copilot fill it in. Yeah, this is totally valid, frankly. So this is a settings struct. We can settings dot read dot first name. Theory. Yeah, that works. You can run it. Errors. Yeah, so John is printed. This totally valid way of doing state. This is like just normal Rust. You're not going like hyper architected. Say randomize, fn randomize. Let's just let's just do mark doge. You could call. We can make a button. Click. Move. Yeah, cool. Setting that right to randomize. No complaints. Yeah, so we're just literally calling mutable methods. React people will tell you this is sacrilegious and you should not be mutating state. It definitely seems like the JavaScript world is coming around to mutation again. I think the big thing JavaScript people have is like mutating two things in random places, and objects being loosely connected means you can just have very disjoint state. In Rust, we have and mute self. Like we're very clear when things are being mutated. So I think we have more protections over the stuff that the JavaScript folks worry about a lot. You can imagine if you had like RCs everywhere. Like JavaScript is basically RC reps just everywhere. You can imagine how they get like messy pretty quick. But like this is totally valid app. On click, it's mark. So you can architect it like this. You can even provide this in context. So provide context. Settings. Oh, no, yeah, it's a signal. So now, well, I'll put this in hook. So I think it's like use context provider. Yeah. So this is like setting up a context provider. Any downstream component can use this. So we'll make a child real quick. I'm not gonna say I necessarily recommend just like globbing mutable state everywhere in your app. Yeah, but it's totally feasible. User settings, actually, this needs to be a signal. Yeah. I mean, I've never really seen it in Rust that it's this easy to do state. I think this is like, personally, I think this is kind of incredible that you can even do this. And let's run this again. John Mark. See, yeah. So same thing. So I mean, it's really simple. This child is taking no prop. It doesn't even have the component macro on it. It's taking no props. So this could be as far away deep in your app as possible. If you have a really big glob of state, then you might run into an issue where, well, anytime someone changes user settings, all the components that use context of like the signal rerun. So maybe this component only cares about first names. So you can do something like use memo, consume context, signal. So we're consuming the context, and then we're just gonna pull out read first name clone. So we're going to make a local. Yeah. Oh, this is read only signal, so we don't even need first name. Yeah. This is a read-only signal, so you can't actually modify it. And all it's doing is consuming context, clone read, and then cloning the value out. This is like, I say this is like the low IQ way of building an app that's actually the high IQ, like the curve. This is like the mid way of like, yeah, just stick all your state into a big blob and then pull it out when you need it. So you could, you could wrap this in your own hook, like a use first name hook or something like that. The alternative way, if you want to get fancy with this, is user settings is actually a glob of signals. So derive, copy. All of these are signals. You don't have these methods on it anymore, but you just play with the values themselves. And then we can call oops, signal new. And we actually, we don't inject it, inject something like this. Now we have very precise state. So this context provider, does it actually return the value? Settings? Yeah, it does. Okay. So we don't have a like a randomized method. You'd have to build well, actually, I deleted the randomized method, but you can actually see how you can build. Um, uh, so yeah, you can still have methods. This is taking and self instead of and mute self. These need to be mutable. Technically, this will technically need to be mutable. But we can then settings.randomize. And this is nice because we're not actually calling write on the entire settings. We're only calling write on the relevant values. Oh, like that. Mute self. Cool. Yeah. So we're building these methods. These are all signals. This is like hyper precise. This first name thing is, yeah, it still works. We actually don't wrap it in a signal anymore. So we have user settings. We're consuming the context, and then we only get first name. And we can do it like this. So we don't even need to memorize this anymore because this signal is automatically memoed. This is the smarter way of building big apps that have lots of values that change. So it's still the same pattern. You could theoretically do like a reducer type pattern. You can make a message type, broadcast it up. But this is hyper precise. So now this child component will only re-render when first name changes. And you can see how this expands to like collections as well. So you don't have signal vec or families or whatever like the MobX equivalent is yet. They will come at some point. But the idea is there that, yeah, you can wrap a collection in a signal. You can wrap strings and signals. And children are hyper precise in the values that they subscribe to. Yeah. I hope that answers the question. Oh yeah, places to help out. We, I think Evan is way better at managing the tracker than I am, but there's a label for good first issue. Oh, dang it, he's faster than I am. Yeah, good first issue here. We'll go through some of the stuff and I'll talk about it. There's some obvious stuff like switching to tracing in a number of places. The STD library, so Dioxus. This I'd say is a great place to get started, and you have the creators here, which are fantastic people. There's honestly a lot of really cool stuff. This needs to be updated for the new version of Dioxus. Um, there's just like infinite things that could exist here, doing like the camera or oh, we have internationalization. There's a whole wide range of stuff. Uh, the issue tracker, if you want to contribute to Dioxus, actually has a lot of easy stuff that is super important. Um, so basic things like the RSEX auto formatter is sometimes, or I think this is hot reloading. Yeah, this is hot reloading. We just don't handle tab characters properly. if you want to dig in and fix that, that'll like unlock hot reloading for a number of people that use tabs instead of spaces. We have hooks that don't exist. We should update some of this. We have a roadmap as well. Where's projects? This was updated last week. We flew through signals. We just keep going, and then there's some stuff that we haven't done yet for 0.6, like trees and the helmet. But there's like a number of things that you can help you out in the chat. I'd say STD is a great place to get started. I'd say there's a lot of bugs or like small bugs or tweaks. The command line is a great place to get started. Logging things, error handling, documentation. Oh, Notion roadmap has not been fixed. No, not yet. Yeah, we do need to update that. Yeah, Dioxus Core is it will become more accessible in the new 0.5 version. We are switching away from like lifetimes everywhere to static values, like like RCs in a number of places, much easier the new source code to be able to chew through. I kind of go ahead, Evan.
Yeah, the new STD also has, or the new core has no unsafe, so it should be a lot easier to not break everything.
What do you think is a good place to get started with? Like, I don't know. I'm very like scoped into core at the moment. What is like the wider, the bigger picture of where people can get started?
I would avoid core. All of the good first issues on core are good first issues if you really want to use core. But core is generally just more like in-depth and interconnected part of Dioxus. Yeah, the CLI is good, Dioxus SSD is good, and the doc side is really good. Uh, yeah.
Yeah, I think charting libraries. We have okay. So there's a bunch of native stuff that's happening. Yeah, we have a charting library. Um, Things like rendering. I don't know, like rendering math characters, like whatever is like kind of important to your use case. I'd say like we have a charting library. I built one off of Plotly at some point. Dioxus community, nice. Resize observer animations. Yeah, I think people always ask about resize observer on desktop, and this is something that you could build. I think we have built at some point. Yeah, maintaining the libraries in Dioxus community. Things like resize observer animations. There's just a number of utility things, especially making them cross-platform. Oh. Great as well. Yeah, there's just so much surrounding Dioxus that could be made better.
Yeah, I saw the issue. I need to get a hold of a Linux computer and test it out. I couldn't reproduce it on Mac OS or Windows, but uh, there's probably some like caching that's getting overwritten by Rust Analyzer or the CLI. I know you tried switching either the web or the desktop cache directory so that it builds, or Rust Analyzer builds with the upper desktop features. We might need to like try the alternate one. Yeah, it's been like a issue on Linux for a while. We've had like sporadic reports of it. Uh, Something with Rust Analyzer and long rebuilds. I'm guessing it's related to this issue somehow. I could try it on a Linux. I have an Ubuntu computer that I haven't gotten out for a while. That I could try it on. I'm not sure if I'll be able to reproduce it with that though.
If you know how to mess with GitHub Actions, you could try adding Pop! OS to our like matrix target. I mean, it seems like some people use it. I mean, that obviously won't help us debug the issue, but we might be able to, like, if it's added to that thing, we might be able to write a test for it and then like catch it in CI so it doesn't degrade. I think it's, yeah, I don't even know if it is. I know Ubuntu is obviously. Uh, there's a number of CI stuff that we don't do. If people want to mess with CI, getting binary sizes of apps over time is really cool. There's some projects that let you track stats of the project over time, and then it makes like a cool like web page for you. I know Boa, like the JavaScript interpreter written in Rust, they have like a performance page. It, Boa Rust, which is really really cool. So like every time they make a commit, they can see if it goes faster or slower. We would love something for binary sizes, compile times, and run times. That way we know we added a dependency like why everyone's compile times went down.
You also has something like that. If we could run like the JS framework benchmark right in PRs, that would be so great.
Oh, yeah. I was wondering when Tauri was going to release something. I don't know why this is like not under the Tauri brand, the updater thing. Mm. Well, I mean, yeah, Tauri's a business, right? I don't know what Crab Nebula's relationship to Tauri is. I think it's some of the maintainers building a business around it. Mm. Yeah. I know there were some questions before. Oh yeah, those were questions from last time. The notes for the 2024 Q&A. We addressed some things. So like the launch builder, we have I kind of want to show this off. Is cool just to like share it. The new launch function is pretty slick. So let me go back to this app actually. Dioxus is rebundled. uh, when you add Dioxus, add separate renderers now. Let me make this bigger. It's just Dioxus, and then you turn on features. So desktop, full stack, SSR. They all know how to work with each other. We couldn't get that before, but we do now. We're much smarter. So there's no more Dioxus desktop. It's like Dioxus, and then you turn on the feature. So if you're going to build an app today, like the Dioxus dependency would look something like um, version equals 0.5, features equals desktop, something like that. This makes it easy to do multi-platform builds, like a big thing. So I'll turn this back on. When we run in default, if we get server functions in desktop, when we run on the server, it will make server stuff. For this particular example, I haven't turned on my server functions yet. I don't have a single database going. But this is cool because we can create a new launch builder. We can add a config, and then we wrap it in this desktop macro. And this code will only execute when we run with the desktop feature running. So we can actually turn on a bunch of different configs. Yeah, we could do like a web config or something. I mean, this is not real thing, but like you could do full stack config and set up the Axiom server. You could do like a mobile. So you have different configs for different platforms, but it's still the same app. The new way of doing it. So yeah, Dioxus 0.5 will also be breaking in terms of you're gonna have to start removing dependencies because we've rebundled stuff. Uh, we give you the router as well. Where's the cargo? Is terminal access? Yeah, we give you a bunch of stuff. So we give you you even get the TUI renderer, hooks. You get the router, mobile, desktop, live view, all under one thing. And these are just features. We got a lot of features, but when you turn them on, and it also means you get things like a warp server for free or a rocket server. You don't have to add it explicitly.
Sorry, can I ask the question with the mic?
Yeah, yes,
Yeah.
please.
The question is
Yeah.
about adding our platforms. Yeah, sorry, I'm bad at English. So the question is that in Russia we have appearing new OSs, no, operating systems that based on Linux. So the question is there opportunity to add support to such platforms? Because I heard the news that some of open source projects are declining to work with supporters from Russia.
I would say,
If you
I mean,
Mhm.
yeah. I mean, we have nothing against adding more platforms. You're probably limited by what Rust will let you target. Um,
Uh, what's
like
what's
the
the
standard
problem with
library.
Rust? Because they have a standard library with Qt. It works. I guess I can just transfer it to Dioxus, maybe just Rust, and like make some bridge in the future, of course. So
Yeah.
there's no problems, yeah.
Not that I'm aware of. I mean, if there's a supply chain issue, um, it's
Mm,
probably not Dioxus's fault. You know what I mean? Like,
what do you mean by
if the
supply
library doesn't
chain?
work. Yeah.
Ah,
um, we
yeah.
use we use like web views. So as long as you have a web view, I mean, we were working on
Yeah,
native
we
web views.
have in this OS like they bundled Firefox engine, so they have a view. So I guess there's wouldn't be any problems.
I believe on Linux, if you have Firefox, it uses Firefox as your web view engine. I haven't
Mm.
looked at that in a while, but I believe that's how that works.
Okay, great. Thanks.
Anybody have like questions or code snippets or ideas? I mean, we have an ideas channel, but it's always good to get a sense of like where where people want to go or see things change or something specific to the use case, or just like talk about what they're working on. It was cool to know what everybody's up to. We need to get the OIDC. I really want to push a cleaner version of the OIDC stuff. I went down that rabbit hole for a long time and really got into it. OIDC is super complicated, way more complicated than I was expecting. It'd be cool if that was a package or something. I think the Rust implementation is super hairy. Um, yeah, Josh, this is a great question. Like, if you want to work on this, we will help you. Like, if you want to make the CLI, oh, if you've ever seen Vue, they have tools that are really good, right? Like, you can add plugins and stuff. We're kind of going in the Vue direction a little bit. So, like, we're adding plugins to the CLI, kind of like a Vite thing, Vite. They have like a GUI. There's a number of things. Part of me says UI should live in the CLI. The other part of me says you can do way more if you have like a window with CSS in it. So I don't know. If you want to have a longer conversation about that, we can talk about that in like the direction we want the CLI to go to. I think it'd be awesome if the CLI was interactive. Like you could turn off and on hot reloading or reload a plugin or something like that. There's the very infinite design space of like making dev tools better. It's a much longer conversation. Wait, oh, you've done a lot of work for OIDC. Yeah. And this, so are you doing an OIDC server yourself? Like you're spinning up the server, or are you using someone else as a provider?
Hey, can you hear me?
Yeah, I can hear you.
Yeah, so I'm just taking the example, and I'm using Cargo Lambda to spin up a Rust Lambda on the back end, and I'm using a CloudFormation template to enable all of the OIDC stuff. And I've got a separate project for that. And then now I'm just trying to connect the front end, the authentication layer, and make it all clean. And then the presentation I want to put together for my Rust meetup later is, hey, look, I got front end Rust, I got back end Rust, and now I've connected them using authentication. So that's where I'm headed.
Awesome. Yeah, you have the Lambda. Which do you have your Lambda set up? Is it in this repository?
It's in a repository called Cargo Lambda prototype. I'll send it. But
Okay.
I got it now so that I can just say like, sam.deploy, and it spins up real quick. And then I say sam delete, and it comes down. And so whenever I'm working on the front end stuff, the back end is pretty quick to bring up and pull down. And eventually, right now, I'm using the AWS Cognito stuff, but
Mhm.
eventually I want to get to using Google as the identity provider.
This is really cool. It would be awesome to get it working in our. So we have server functions. I mean, we haven't really got it to the point where it's like splitting the build into lambdas, and that would be a really cool feature, like being able to select a server function or a lambda. Um, that way you could just like add the function next to your app, and then it's like doing the, the request. So you're just serving the like a 200. So this isn't the OIDC server itself, or just like saying yes to auth, or like
So
auto always auth.
this is all this is the identity provider stuff, the Cargo Lambda. Oh, I'm sorry. It's both. It is it is a Lambda which I want to protect with authenticated authorized access, and
Mhm.
it is a CloudFormation template which sets up the identity provider using AWS Cognito, um, which the Jamstack front end Dioxus single page app that's uses static pre-rendering with client side hydration, then connects to the back end to get the tokens.
Well, yeah, yeah. I haven't played much with the lambdas. I was stuck with like easy to deploys on Amazon, um, or like Cloudflare workers.
Yeah,
Yeah.
the Cargo Lambda stuff is relatively new. There's some new YouTube videos about it, like the recent reInvent conference, AWS reInvent conference had a real good video on it. But
Mhm.
there's and then AWS Rust SDK just went general availability just a few weeks ago. So, and then of course the alternative is things like, Fermion Spin.
Yeah, Fermion's the WASM provider, right? They do Lambda, or like, is it WASI, not WASM?
Yeah,
Or they do
WASM, and then they support WASI, and they're really excited about the WASM modules because that allows them to take different pieces written in different languages, compile the WASM, and then plug them together. Um, what's been slow for me in adopting the Fermion Spin stuff has been, I haven't found a real good example of the authentication layer. So far all the
Mhm.
examples are primarily, if you were to write a REST API and open up to the world, here's what it could look like.
Yeah. Is there an OIDC server in Rust? Well, from what I understand, there's like two parties in OIDC, right? You need a server and you need like a middle layer.
So the front end, assuming, Jamstack, the front end will go to the back end and say, hey, where's your authentication server? And it'll get that URL, and then it'll go over there and say, hey, where's your login URL? And then it'll pop up a window or something from the identity provider hosted. And the
Mhm.
identity provider says, hey, do you want to create an account, or do you already have an account and you just want to log in? And so they log in, and then it uses a callback
Mhm.
to the single page application. And that's where I got stuck for a while because I was having problems with that with the static pre-rendering on Dioxus. And so I was able to get a workaround. My thanks to you all for providing that workaround just recently. And so now we get to the callback page. The callback page gets an authorization code, and then it uses there to go to some token server and say, here's my code, and here's some other data to confirm that, this hasn't been hijacked. Now give me a token. So now I've got a token. Then I go back to the Lambda and I say, hey, Lambda, here's a token that says I have access to you. And so
Mhm.
it's fine with that. Then the front end every once in a while is going to refresh the token.
Yeah, the thing that I didn't quite understand with OIDC was the token refresh stuff. Is like either you set a timer for the token refresh and then you go do the refresh, or then you like make a request, it tells you your token's expired, and then in that request you go back and forth to do the refresh.
Yeah, so the way I've done it before is I would, when I was doing like Angular stuff, is refresh, I would use the refresh token to get an updated, access token. Um, and I'd usually try to do it about halfway between the time when the access token was about to expire. And
Mm.
I mean, let's see here, the limitations on that are, let's say you had someone that you needed off of your system now, right? And so in the back, you go in and validate their tokens, but they've still got a token for a while. And if you've got a long period on that, and so it becomes a game between, how fast do you want to be able to have them lose access versus, and then on the server side, on the Lambda side, if I wanted to, every time I get that token, that request, I could go and verify it right then, but
Mhm.
that's another trip. So
Yeah, that was always the tricky part of JWT. We used to do like embedded stuff or pseudo embedded. It's not like super embedded, but like single board computers, edge deployed kind of thing, like out in the field. And we built this like JWT infrastructure, and it was like kind of not like we ever needed to revoke those devices, like not that frequently. But JWT kind of just lasting out there made that difficult because that token's always authenticated, especially like in foreign environments. You're not always checking like a ban list, or you know what I mean.
yeah, yeah. So I'll put together like a little tutorial on my website or something when I've got it all working.
that'd be really cool. Once we get, I think it'd be even cooler. We can use server functions. We can like deploy them onto lambdas. I don't know how, I don't know what the API surface there would look like, but like being able to add a server function that does like the request in the same app. That way you kind of have your like one file and you deploy that and it does the static pre-rendering. It spins up the lambdas for you. Like it kind of does everything you need to do.
See, I'm a
I
big
think we
fan of
get
Jamstack, so I like to keep those separate.
that's fair. Yeah.
I mean, right now it's really nice that I can just deploy everything from my content delivery network.
That's using the Amazon one or
Yeah, I mean, just
Cloudflare.
hypothetically, any content delivery network. I'm currently using um the Amazon CloudFront, but I guess my point is I don't need a server up and running um to because everything's statically pre-rendered, and the only time I ever need to go back to the server is if I actually need to access data via a REST API or something.
Yeah, I think that's kind of so maybe we don't like communicate server functions well. They're kind of designed around that of like your main site is static pre-rendered. You get a bundle you can deploy to a CDN, like the pre-rendered unhydrated content. And the functions themselves are designed more of like a lambda. I mean, you can run them from a server, but they're more designed for lambdas because they're not really stateful. Well, they're kind of stateful. Like you can put context in them, but they're really meant to be reading from a Redis or reading from a SQL or something like that. Like not like two server functions shouldn't impact each other because if you scale, in theory, you should just scale vertically, but if you scale out with lambdas, two server functions might not be running on the same server, so you can't rely. They're more designed around that model of you have a bundle, you put that on a CDN, and then your functions just are living in some worker somewhere. I mean, you can put them on a server like EC2 thing, but they're more for like worker type environments. Cool. I want to. Well, I'm probably going to end it soon. But if anyone's got any like final questions, or remarks, or anything, if not, we'll just head out, make breakfast. Cool. Okay. Well, thank you guys for coming. If you have questions, just ask them in Discord. We're very active. We'll answer whatever. All right. And thank you for recording today, Doge. I appreciate it. Yes. Oh, we're gonna put out a YouTube video that like walks through the new Dioxus. I think that's gonna be an important thing. Probably be this environment. Maybe not me looking straight at the screen like this. Maybe I use my monitors, but I think a walkthrough video of the new state and all the questions you guys asked. I think it's great that it's in an office hours, but I think it'd be even better if it's in a YouTube video that people can follow along with. Docs are great. YouTube videos are sometimes even better. Yeah, yeah, Doge. If you have ideas for content, I got a nice camera, I got a nice mic, and I got Final Cut Pro. I finally bought it, so we should make some videos. I think after point 0.5, I kind of want to switch gears a little bit. We've been doing a lot of code writing. I think there's a lot more like community building, marketing, advertising, ecosystem stuff. Yeah, yeah, good YouTube short. You can put it on TikTok. The kids are on TikTok these days. Yeah, I think a YouTube channel would be good. Signals, I hope, are the last time we have to touch state management. I think there's so many primitives now with state, and we've like simplified it enough. It's like one crate does everything, play all the pieces. I think once that's done, we're like happy with state, and we can just make a lot of content around building apps using like signals as that primitive. Um, there's hopefully a lot more content in the future in terms of like marketing. Yeah, it's basically a new library at this point. I mean, it's like the same bones. uh, yeah, we should make an effort. We kind of know who's using Dioxus in libraries through like the GitHub dependency graph. So we should make an effort to like compile the list of crates out there that are using it, and then like make PRs updating things. It'd probably be a pretty big effort, but I think there's like a lot of icons crates out there, or state management stuff, or hooks for observers and things like that that will need updated to the new version. SCD, I think, being the main crate we want updated when we go for the release. Okay, well, I'll go make breakfast. It's good to have everybody for office hours.